At the northern edge of Bengaluru, where the city slowly gives way to open skies and quiet trees, there is a campus built for one purpose: to think. Here in Shivakote, the International Center for Theoretical Sciences of the Tata Institute of Fundamental Research, ICTS TIFR, brings together scientists from across India and the world to understand how the universe works in its deepest language.
It has been, I think, very fulfilling to be heading this institution for 10 years. It has a unique environment which we are trying to create for people to have creative ideas, breakthroughs, and getting young scientists, students, other researchers to also feel that they can think ambitiously.
This is not a place of rushing crowds and flashing instruments. It is a place of blackboards and equations, of slow conversations over tea, of ideas that are allowed to grow. Founded in 2007 as a new center of TIFR, ICTS was imagined as a home for frontier research across physics, mathematics, computer science, and the sciences of life, a place where theory could travel freely across disciplines. Today, under the leadership of its second director, Professor Rajesh Gopakumar, ICTS stands as a unique experiment in India, a center that combines in-house research, international scientific programs, and a strong culture of outreach under one roof. At its heart is a simple belief that if you bring curious minds together and give them the time, space, and freedom to think, something remarkable will take shape.
So one of the things is that, a lot of Indian students used to go abroad for schools, conferences, stuff like that. Now we can have them here. If you want people to work sincerely, they must have a sense of belonging, that they are valuable, that they are contributing to research also. Everybody is contributing to our work.
This is the story of ICTS TIFR, of the people who built it, the questions they ask, and the ways in which their ideas touch the world. This is the story of a place where ideas take shape. Research at ICTS stretches from tiniest building blocks of matter to the largest structures in the cosmos, and from abstract mathematics to the physics of life. In one building, a group works on string theory and quantum gravity, trying to understand the geometry of space-time itself. In another, numerical relativists model the ripples in space-time that we detect as gravitational waves, linking their equations to experiments like LIGO and Virgo. Down the corridor, experts in statistical and condensed matter physics study how order and randomness emerge in materials, how phases of matter appear and disappear, and how collective behavior can surprise us. The research groups here span complex system and fluid dynamics, understanding turbulence, weather, and flows that never quite sit still. Space-time physics, from black holes to early universe, mathematics and computations, dynamic systems, geometry, probability, and large-scale numerical simulations, physical biology and interdisciplinary science, where tools from physics and artificial intelligence are used to probe living systems. At ICTS, physics and mathematics do not stand apart. They challenge each other, and in that dialogue, new ideas are born. ICTS hosts diverse cutting-edge research areas powered by exceptional people. In condensed matter and statistical physics, Abhishek Dhar studies non-equilibrium systems and heat transport. Manas Kulkarni explores quantum many-body dynamics. and Deepak Dhar helps shape how we understand critical phenomena and emergent complexity. In high energy physics, Ashok Sen continues to redefine string theory and black hole physics. Rajesh Gopakumar probes gauge gravity duality, asking how space-time itself emerges from quantum theory. In gravitational wave physics, P. Ajit translates Einstein's equations into observable signals, modeling black hole mergers detected across the universe. In fluid dynamics, Rama Govindarajan studies instabilities and transitions to turbulence, revealing how order gives way to chaos. And in the physics of light, Vijay Krishnamurthy applies the laws of fluid dynamics and statistical mechanics to understand living systems and pattern formation. From quantum matter to living systems, ICTS pushes theory to the edge of the unknown. The questions are advanced, but the spirit stays very human. Curiosity, rigor, and the willingness to be puzzled. On a typical day, a problem may start as a line on a page, turn into a set of equations on a blackboard, and then become code running on a computational cluster. Ideas move from chalk to screen, from one office to another, from one discipline to the next.
I've written 2 or 3 papers on the Indian monsoon. We've looked at that from a statistical point of view, looking at rainfall data all over India. So the rest of it has all been fundamental fluid mechanics, but connected to geosciences, if you see what I mean. So this cloud thing is one, where I look at turbulent flow and how raindrops grow in that environment inside a cloud. So then I look at fundamental things which could be pen and paper work. It could be writing some differential equations, ordinary differential equations, solving them with paper pen and solving them on the computer, and then going to Navier-Stokes equations which describe the fluid flow and solving them on a bigger computer. So like it goes in these steps and we connect like each step to the other.
Fluid dynamicists here look at how clouds form, how droplets break, how flow transition from smooth to chaotic, phenomena that shape our monsoon, our climate and our technology.
So the problem of phase transitions has a long history, about 200 years.
Okay.
Because it is a very spectacular phenomenon. Like you look at ice and heat it up and suddenly it becomes water. So this thing is spectacular, everybody can see it, is everyday experience. Can we understand it?
It's a question.
Whatever that means.
Yes.
As a physicist, can I understand melting?
In statistical physics, simple models of spins and particles help to explain complex behavior, from magnets to materials, from random walks to networks.
What I find truly interesting is that almost every culture across the planet has a tradition of mathematics. Right? Everyone has their own numbering system, their own ways of counting. Everyone has contributed to this huge body that the mathematics that some Greek person did, or a Babylonian did, or an Indian did, sitting in Kerala, like it all fits together. And so I think the reason why we are interested in applications of mathematics is the reason why we do mathematics. It's a human activity. It finds its use in all human activities, and it's one of the oldest activities that we've been doing.
Mathematicians and computational scientists translate intuition into precise theorems and efficient algorithms, often in close dialogue with physicists. Beyond traditional boundaries, ICTS is also stepping into a new terrain. Together with the National Center for Biological Sciences, ICTS has helped launch Caliber, a center that brings artificial intelligence into biological research and education. Here, no topic is isolated. A question in biology may use tools from probability. An issue in astrophysics may be approached with techniques from condensed matter. The walls between fields stay deliberately thin.
I'm also happy with the atmosphere in which our scientists work. They are very collegial. They are always discussing with each other. Several new collaborations have come at ICTS because of people talking across different disciplines. So we try not to have disciplinary boundaries, and people have been talking across disciplines and coming up with new ideas.
In the end, what defines research at ICTS is not just what people work on, but how they do it, collaboratively, slowly, and with the confidence that deep problems are worth the time they demand. ICTS is not only a research hub, it is also a place where the next generation of scientists learn how to think, how to question, and how to create knowledge. The center runs integrated PhD and PhD programs in areas of physics and allied disciplines, blending advanced coursework with early research exposure. Courses are demanding, but the atmosphere is informal. A lecture may begin with equations on the board, but it often ends with students and faculty continuing the discussion in the hallway or over lunch.
The open discussion that we have, that's what I felt. It's like you can just very openly even you can ask your peers about the kind of questions. Even to the faculties you can ask. The seemingly stupid questions, but maybe that is important. So that they will welcome those kind of questions. The discussions with the professors are also really wonderful. The courseworks are really organized for the PhD and integrated PhD level in a very coherent way. It's not like very bulged out or something like that.
For many students, the difference is in the mentoring. Supervisors are accessible, doors may stay open, students are encouraged to attend seminars well beyond their narrow topic, to sit in on programs, and to meet visiting experts from around the world. ICTS also holds a vibrant community of postdoctoral fellows. They come from India and abroad, bringing fresh ideas and experience. For them, ICTS offers two rare gifts: academic freedom and critical mass.
ICTS fosters a very collaborative environment, and it fosters an environment which is conducive to good research, especially in theoretical sciences.
Culture in ICTS. If I have some problems, I can go and ask a colleague or a friend of mine who's working in condensed matter or high energy, for example, some techniques that they use, and that has helped me in my research.
Postdocs can choose bold problems, form small working groups, and collaborate across research clusters. The size of the institute is just right, large enough to be diverse, small enough that people know each other. Every year, ICTS also welcomes visiting scientists through schools, summer programs, and focused workshops. For many undergraduates and master's students, this is their first direct exposure to cutting-edge research.
It's an immensely stimulating place intellectually, at least as far as Indian institutions go, and as far as I've seen many Indian institutions. If you're sitting at a dinner table or a lunch table here, everybody's talking to each other, everybody's talking about all kinds of things, starting from etymology to sociology, to all kinds of things, right? And it's never just physics, never just biology, never just chemistry. You hear all kinds of things and you get to learn a lot of things. So it's a very stimulating place, to say the very least, and it's a brilliant place. Yeah.
These interactions leave a mark. Some visitors return as PhD students, others carry the experience back to their home institutions, multiplying its impact. In this way, the academic life of ICTS extends well beyond the campus. It becomes a network of people who carry the culture of thoughtful, rigorous science wherever they go. What is it actually like to live and work here? You notice the blackboards first. They line the corridors, the lounges, and some even the open spaces. Equations appear, disappear, and reappear, traces of conversations that may have started in a seminar and continued at dinner. ICTS was designed not only as a set of buildings, but as a conversation space corridors that curve gently, courtyards that invite people to pause, a central green that acts like the heart of the campus. The culture is quite egalitarian. A first-year student can question a senior professor in a seminar. A visiting researcher may spark a new line of thought with a casual remark at tea. There is some understanding here that good ideas can come from anywhere and that criticism is a part of care. Arguments are sharp but not personal. What matters is the problem, not the position. In the evening, as the light softens, you often find small groups gathered round a blackboard outside or walking slowly along the paths that loop around the central lawn. A question that began in the morning may still be alive at midnight. One student described it simply, it is a place where even silence speaks mathematics. One of the most distinct features of ICTS is its programs. Scientific meetings that range from intensive schools to long-term thematic visits. Unlike many institutes where conferences are occasional events, at ICTS they are central to the mission. Every year, the center hosts a few dozens of such activities. Flagship meetings, focused workshops, advanced schools, and interdisciplinary gatherings. During a program, the rhythm of campus shifts. Mornings begin with lectures, afternoons are for problem sessions and small working groups. Evenings often feature informal talks or conversations that stretch past dinner.
ICTS has a mandate which is rather unique in India compared to other institutions because it combines in-house research with programs as well as, of course, outreach. Programs that are held here are for different durations and there are different kinds of programs. There are some programs that run for several weeks to months, while there are others that run for just a few days, and then we also have programs that are centered around lectures, few lectures given by a special invitee, an expert in his or her area of research.
These meetings do more than share results. They create collaborations. A conversation between a mathematician and a physicist can become a joint paper a year later. A student's question in school may lead to a thesis topic. ICTS has also adapted its programs for online age, running virtual and hybrid events. Through its programs, ICTS acts as a kind of scientific crossroad, a place where paths meet and where ideas leave together transformed. For all its advanced research, ICTS never forgets that science is also a public conversation. Outreach is woven into its identity. The center regularly hosts public lectures by leading scientists. Auditoria fill with school students, families, and interested citizens. Questions are lively. The atmosphere is serious but never intimidating.
So ICTS also is a place where a lot of programs are conducted year round. So this brings in a lot of scientists from the international arena to the campus. Some of these scientists are very good public speakers also. We bring these speakers to the public through public talks. And we have a whole range of public talks.
Beyond lectures, ICTS runs outreach visits to nearby government schools using simple hand-on activities. These visits are small in scale but large in impact. For many students, it may be the first time they see science as something they can do with their own hands. ICTS also maintains an active online presence, recorded lectures, blogs, and newsletters. Women in science, diversity, and inclusion are recurring themes. The message, repeated in many forms, is simple. Science is not distant, it belongs to all of us. In a country as large and as young as India, such sparks matter. ICTS outreach is a reminder that the journey of an idea often begins in a child's first moment of wonder. Good science needs more than just good questions. It needs the right environment. The ICTS campus was designed as a world-class residential institute. Offices, seminar halls, housing, and recreational spaces woven into a coherent whole. Academic blocks hold lecture theatres and informal discussion spaces. The iconic inverted cone library sits in the center. Behind the scenes, powerful computing clusters support simulations, while high-speed connectivity links researchers worldwide. Residential blocks, guest houses, and shared spaces allow visitors and residents to live, work, and think together. The campus also includes a cafeteria, sports facilities, walking paths, childcare, medical support, and spaces for art, music, and reflection. The architecture fosters scientific interaction through open courtyards, pedestrian pathways, and thoughtfully connected buildings. In short, the campus is more than a backdrop. It is an active participant in the life of ICTS. For all its successes, ICTS, like any living institution, faces challenges. The first is scientific. The frontiers of theory are moving fast. Keeping pace means attracting outstanding faculty, supporting postdocs, and entering emerging fields without losing depth.
I feel that we have a strong foundation, but we must build on it. We have to grow in numbers much more compared to our population. I think that it's a simple law of statistics. I think the more people there are exploring more things, the more ideas will come. It's a law of large numbers, and that is what the modern scientific system, I think in the US, China, and other places, the number of researchers per 100,000 population, ours is only a fraction compared to like 1/5 or 1/10 compared to US or China. And that has to increase if we have to have really impact globally in many areas.
The second is structural, strengthening resources, funding, and staff. The third is social, making science more inclusive, reaching students from smaller towns, and building wider collaborations. Yet, these challenges are also opportunities. With initiatives like Caliber, ICTS is exploring how artificial intelligence and theoretical methods can transform biological research. New programs in machine language, gravitational wave astronomy, and advanced mathematics show a willingness to engage with urgent scientific questions.
We need to create that visibility in India that there are intellectually attractive institutions where you can spend time and gain knowledge and be mutually enriching. So this kind of internationalization of our scientific institutions is very important. We should benchmark our impact, our scientific contributions with global benchmarks, not just how we are doing relative to each other.
In the coming years, ICTS aims to deepen its role as a global node in the theoretical science, rooted in India but connected to the world. The vision is clear: to remain a place where difficult questions are welcomed, where young people are trusted with real problems, and where science is pursued with both precision and imagination. As the day ends at ICTS, the campus grows quiet. Lights stay on in a few offices. A blackboard outside still holds the remains of an argument. Somewhere, a student replays a lecture. Somewhere else, a school child remembers a spinning toy from an outreach session. And in a seminar room, a small group continues to discuss a problem that will not quite let them go. This is how science actually moves, not in leaps, but in patient collective effort. in questions asked and re-asked, in ideas that take years to mature. ICTS TIFR is one node in this global network of thought, but it is a spatial one, a place in India where frontiers of theoretical science, advanced training, and public engagement meet. This is the International Center for Theoretical Sciences, TIFR Bengaluru. This is where ideas take shape.